Nation Faculty Development Program on Data Science Tools organized by the Department of Artificial Intelligence and Data Science of Ishwari Engineering College. Our today's session is on TensorFlow. It's an honor for me to introduce and welcome the keynote speaker of the day to our session. Dr. Rusu Tamilarasan is currently working as a senior project lead at HCL. Dr. Rusu Tamilarasan has completed his Doctor of Philosophy at College of Engineering, India, and has worked for many top companies like IBM as advisory system analyst and at Wipro as associate consultant. We're happy to have you with us today, sir. The session is yours.
சார், நீங்க பேசுறது எதுவும் கேட்கல சார் எனக்கு. ஓகே. மத்தவங்க கேக்குதா? ஓகே. தேங்க் யூ. ஸ்டார்ட் பண்ணுங்க. Good morning, everyone. I'm facing some audio issue. I'm just sharing my PPT. So I'm Dr. Russo, Senior Project Lead, HCL Technologies. My topic is machine learning using TensorFlow. Writing program is our job. Checking condition is our goal. Testing code is our primary. Making platform is our profession. Cleaning memory is our practice. Showing demonstration on time. Chatting with program is our hobby. Speaking with logic is our passion. Playing with for loop is our need. Optimization is our objective. Living as a programmer. So machine learning is in between artificial intelligence and deep learning. What is artificial intelligence? Artificially, we are embedding our knowledge, human knowledge, in machine, the form of program, algorithm. We are embedding the programming inside the memory. Machine has some memory. Inside that, we are embedding. So artificially, we are making machine to work on that for a particular problem. Machine learning is a field of inquiry devoted to understanding and building methods that leverage data to improve performance on some set of tasks. It is seen as a part of artificial intelligence. Machine learning algorithm build a model based on sample data known as training data in order to make prediction or decisions without being explicitly programmed to do so. Machine learning algorithms are used in variety of applications: medicines, email filtering, speech recognition, and computer vision. Artificial intelligence is a branch of computer science named artificial intelligence, pursues creating the computers or machines as intelligent as human beings. There are several applications: web search, recommended systems like YouTube, Amazon, Netflix, understanding human speech such as Siri, Alexa, self-driving cars, Tesla, automated decision making. There are several programming languages used: Go and chess. There are history in artificial intelligence started by 1956 by Dartmouth College. The artificial intelligence goals: detection, reasoning, problem solving, knowledge representation, planning, learning, natural language processing, motion and manipulation, perception, social intelligence, creativity, general intelligence. There are several programming languages or tools implement artificial intelligence. TensorFlow, PyTorch, Keras, OpenCV, SimpleCV, Python, Vika, Spark, Matplotlib, Hadoop also. Now we'll see TensorFlow, how TensorFlow is implemented in deep learning. So first of all, we'll see what is deep learning. Deep learning is nothing but several ways, under several conditions, we are learning the system. Okay, so it is a part of artificial intelligence and machine learning. Okay, so first we'll touch upon why artificial intelligence required. For example, in the road, we have to detect the number plate. By seeing the number plate, it's very difficult gathering the text. So if your car exceeds the speed limit, then human to monitor and note down all the numbers is not possible. So we are keeping on machine, artificial intelligence machine, that will capture and will enter the text in database. Okay, for that we need a program. The program should be embedded inside the CPU or some other machines. There are a lot of branches in artificial intelligence, deep learning, machine learning, and under machine learning, deep learning, predictive analytics, translations, classification, clustering, information extractions, speech to text, text to speech, image recognition, machine vision. Yeah, again, the applications: speech recognition, natural language processing, image recognition. For example, to implement machine learning, there is a data sets: sepal length, sepal width, petal length, petal width. We have to find the species. Okay, we are giving the input to the system, and the algorithm will find out what is the kind of flower. Okay, for that we need training data, machine learning algorithm, and we have to model it and test data, and finally we will find out the accuracy. There are types of machine learning: unsupervised learning, supervised learning, and reinforcement learning. Reinforcement learning by interacting with the space or environment. In this diagram, you will see that this is water and fire. By touching the fire, it will sense, oh, it is fire. By greater than temperature, it will understand that this is fire and this is water. Like that, by touching the environment, it will understand. Okay. What are the limitations of machine learning? It's very hard to implement huge programming concepts. The complex problem cannot be solved by the machine learning. So one of the biggest challenge with the traditional machine learning models is a process called feature extraction. Okay, that is very difficult to do it by the machine learning. That's why we are going for the deep learning. Okay, deep learning models are capable to focus on right features by themselves, requiring little guidance from the programmer. The model also partially solve the dimensionality problem. Okay, so this is the model. Actually, the topic is TensorFlow. Using the TensorFlow, we are going to implement this model. Please take this snapshot. Okay, we are going to implement this model in programming language, through programming language, TensorFlow language. Okay, deep learning is implemented through neural network. Motivation behind neural network is biological neuron. This is a biological, left side is the biological neuron. See the picture, nucleus is there, cell body is there, dendrites receiver there, action terminals. Similarly, multiple inputs and weights are multiplied with the x1 and x2 and so on. Then the processing happen. Finally, the output will be triggered by the transfer function. So this model is going to be implemented by the TensorFlow. So actually, deep learning, several conditions, several layers, by combination of conditions applying inside the algorithm, and we are trying to get out. These are all examples for understanding the deep learning. Various layers are created. Under each layer, the combinations of conditions will be applied, and finally, we are drawing the output. Face detection example. So in every layer, there are some algorithm is going to be applied. This is input layer, hidden layers, 1 and 2. Every layers, we are getting one output. For example, in this input layer, we are getting patterns of local contrast. And second layer, we are getting phase features. At last, we are getting the final phase. These are all applications. Okay, now we'll see how to implement this mathematical model using the TensorFlow. Okay, so this is very, very important formula. For example, this is a model. X1 is going to be multiplied with W1, X2 multiplied with the W2. Similarly, all the X variables will be multiplied with the weightages. Okay, then the activation function is taken place here. Finally, we'll decide. The weights calculated by this formula. Okay, what is TensorFlow? Tensors are the standard way of representing data in deep learning. Tensors are just multi-dimensional arrays, an extension of two-dimensional tables. This is one-dimensional tensors. This is two-dimensional tensors, and this is multi-dimensional tensor. What is tensor and what is flow? Tensors is nothing but the matrix. Flow is nothing but the computational graph. First, we have to build the computational graph. Then we have to run the computational graph. How to build a computational graph? Okay, by writing the program. Import TensorFlow as TF. Node 1 equal to TF dot constant 3. node2 equal to tf dot constant 4. Then print node1 and node2. This is a simple program. Okay, I'm just giving the link where to execute this program. In chat, I'm sending the link. Please click and open this link. You'll get this Google page, Google Colab Research, google.com page. In code, you have to type the program. I have few programs already in my machine. So the simple program is multiplying two numbers. Through chat, you please reply whether you are getting the output or not. Okay. So first I am executing simple program multiplying two numbers. To write the program, you have to import TensorFlow as TF. TF is object. From that object, methods will be used. With the TF dot compact dot v1 dot session as session. Node1 equal to TF dot constant 3.0. Node2 is a nothing but a variable. Okay, like a equal to b, a equal to 3, b equal to 4. Like that, we are assigning the values and multiplying two nodes, and we are getting the output. I'm just running the program. It is executing. Yeah, finally you are getting the output 12. Okay, I'll share this program to everyone. First you try in your machine, then respond back whether you are completed or not. Please respond back whether you are getting output or not. I'm sharing the program with you. Try to execute in the Colab research.google.com and reply back. I'm not able to hear your voice, so please text me. If you are completed, please text me whether you have completed or. Good. Santosh has sent completed. Vishnu Prabha completed. Dr. Rashmi completed. Around 183 participants. It's a simple program. Sashireka madam completed. Keep this program with you and give this example to your students and make the students to write TensorFlow programs. Jayalakshmi madam completed. Okay, I think everyone knows this program. I'm giving another program. Archana madam completed. Ronald Reagan completed. So I'll give you some the next level of program. So next level is we are using session. Okay, this is kind of computational graph. Next, we are going to implement this kind of computational graph. TensorFlow is nothing but matrix plus computational graph. Okay, so this is the graph. How to implement this graph? By assigning 3 values in 3 different nodes or variable. In place of D, we are multiplying B and A. In place of E, we are adding C and B. Finally, we are getting out. Okay. So, till this place, we are calculating. The last one is the session variable. Okay, creating the session object and running the session. And finally, final stage, we are executing the sessions. Okay, I'm just executing this program. So by giving 5, 2, 3, we have to get 5 as the output. So this is the program. I am executing in Colab Research. We are getting the output 5. And share this program, train your site. Please try to execute this program and response back.
Sir, your voice is not audible, sir.
Yeah, I was in mute.
Oh, sir.
I'm sending the third program. Just try to execute this program. So this program is actually, it has placeholder. Okay. So placeholder means getting the input from the, while running the program, it will get the input like scanf. We are passing two values, 1, 3 and 2, 4. Okay. So 1 will be assigned first, then 2 will be assigned, it will be calculated, so you'll get the result 3. Again, 3 will be assigned the variable A and 4 will be assigned in variable B, then the calculation will be done. We'll get 7. Similarly, you can give any number of sets, set arrays, values. Okay. For example, I'm giving 7, 8. Here I am giving 6, 8. So you'll get 4 outputs, 3, 7, 13, 16. You try on your side. Santosh completed. Please try and reply me. Regan completed. Santosh and Regan completed. Others, please. No, Mageshwari madam also completed. Abhinaya madam. Suganya madam completed. Vivekanandan, Dr. Rashmi, Srinivasan completed. Okay, good. So we'll see another program. Dr. Anita. Okay. Next program is to implement the mathematical model, linear model. Okay. So you just see this thing. We are going to implement this mathematical model. So we have to pass x variable, calculate the weights, and apply the function. We'll see how we are going to do. W equal to, we are assigning the variable weight. B, we are assigning the value. X, we are giving the set of values using placeholders. Okay, because we have X is the set of values and B is a constant, and weights will be also constant. Here the linear model equal to weights into X, okay, plus B. So the set of values is going to be applied in this formula and we are going to get the output. Finally, we are assigning initializing tf dot global variables initializer. Then session equal to tf dot session. Finally, we are running the session. Session dot run init. Okay. So the last line is used to pass the value during runtime. The set of values going to be assigned in the place of x. I'm just copying and executing the place of collab. Okay, I'm getting 4 values. Okay, by applying 4 value, I'm getting some um, result, okay, linear model result. If you mathematically, if you work out mathematically, you'll get this output. So first 3, how do you get the 3? Sorry, 0. So 1 will be multiplied with the minus 0.3 and then minus with the minus 0.3. So you'll get 0. Similarly, all the values will be applied and you'll get the output. I'm sharing this program. Please reply back if you are completed. Wasn't completed. Soumya, Dr. Reshmi completed. Regan completed. Kavita madam completed. Yeah, session is used to execute the computational graph. The whole computational graph is going to be executed at last. Okay. The question is asked by Santosh. Good question. Session is going to execute the whole computational graph. See here, session.run is execute the entire complete graph. Okay. Next, we will move on to the other program. Session without session. One cannot we can get the output, but computational graph cannot be executed. Using the session only, we can get the output. We can execute the computational graph. Coding statement, please. What is the session? Without session. Without session also you can print the output, but the computational graph will be executed by session object. Okay, next we will see placeholder and square delta, loss function, how to compute the loss function. Okay, a loss function is measured is how far apart from the current model is from the previous data, provided data. Okay, So loss is deviation between the expected and actual. Okay. So this is the program. See what we are doing till this, we are getting the input and we are applying the model. Then we are initializing the global variable init. Then we are creating the session. Then we are running the session. Okay. Then session for this computation graph, we are passing the input. Till this, you know. The next one is the finding the loss function. For finding the loss function, we are giving the different set of values, applying to this linear model, the same linear model. Okay, so that is the loss function. Okay, we are subtracting y. Here we are doing some model, and we are subtracting y from this linear model, and we are finding the loss. For this y, we are providing this set of values. I'm just executing. So I'm getting loss function, loss values, deviation between the actual and expected. So first we got 0, 0.3, 0.6, same. Okay. So this is the actual, and the loss value is 23.66. So we have to eliminate the loss. I'm just sharing this program to you. Try to execute and understand. If you are not able to understand, ask question. Srinivasan completed. Soumya completed. So this program is used for calculating the loss. Now Mageshwari madam completed. Santosh executed. How we get 23.66? Can you tell? See, already we have some value. By applying 1, 2, 3, 4, and we are giving linear model minus 0, minus 1, minus 2, minus 3. So if you put minus into minus plus. Okay. So by adding this mathematical model, you will get 23.66. Manually, you can work out. Okay. And the loss program optimizing function. TensorFlow provides optimizer that slowly change each variable in order to minimize the loss function. So we are getting the loss 26 point something. We have to reduce the loss. So slowly we are changing the each variables, and we are going to reduce the loss. So this is the program. So optimizer equal to tf dot train dot gradient descent optimizer. Regan asked me, so what is the value which is returned by the function global variable initializer? So this won't return any value. It will be initialize the method. That's it. Here optimizer equal to tf dot train dot gradient descent optimizer 0.001. Train equal to optimizer dot minimize loss. Using these two lines, we can minimize the loss. Okay, I'll just execute the program. So as per all three values we are displaying, the first is the mathematical model values. Second is loss value, loss function value. Third is minimizing the loss function. Okay. So 23 is the loss. We are minimizing into 0.999. So optimizing. Okay. So the optimization value is 0.999. By executing this line, you will get this output. Okay. I'm just sharing this program. Sorry. Try to execute. Ritika completed. Okay. So keep all Srinivasan Santosh completed, Soumya completed. Keep all these 5 programs, and each program is meaningful for every concept. Okay. So understand the concept and apply and try to expand whatever you want for your research. Okay. Then carry on. Sorry for the inconvenient communication. I have not tested my laptop. This is a new laptop only. I have not tested. This is my personal laptop. I'm not able to use my company laptop. So personal laptop I have not tested so far. That's why I'm not able to uh, get your voice. Okay, sorry for the inconvenience.
No
We'll
issue,
meet
sir.
next
We aim.
time in anywhere.
We heard your voice, sir. No problem.
Thank you for the management, Ishwari Engineering College, HOD, faculty members, Revati madam, Dr. Nirmala madam. Thanks for providing such a wonderful opportunity for being with you. Thanks for all faculty members. Around
Thank you, sir.
215 faculties are joined here. Thanks everyone. Thank you so
Sir,
much.
all the days around 200 participants surely joined, sir, because all the participants eagerly and joined this session and learned many things from this session, sir. Sabeda? I think
Yes, sir. I can hear you, sir. Yes, sir. I think he has left the
start
meet,
having
sir.
any network issue, so you can.
Yes, sir. Okay, participants, please make sure to fill the feedback form that will be sent in the group. And thank you for making use of the session. And tomorrow's session is on W by Mr. Murugan Chidambaram, Head of Digital Transformation at Aqua Connect. And the timing is from 11 a.m. to 12 p.m. Please make sure to attend the session. Thank you all. Have a great day. The feedback form will be sent now.